All right, here are solutions to quiz 3 from Math 243. Okay, we're given this sample space that has these 15 items in it. And we want to calculate the probability that our event is an odd number. So what you can do in these, one way to come up with them is refer to our formula that we have that gives you the probability of an event. And what that says is it's the cardinality of the event space divided by the cardinality of the sample space. That's probably a more complicated way than you need to express it. But the basic idea is you just have to count how many things are in your sample space. We got 15 here. And how many things are in your event space. My event space is an odd number. So I got 1, 2, 3, 4, 5, 6, 7, 8. So the probability of this event is 8/15. Easy enough. Probability of this event, same idea. It's the number of things in your event space, the cardinality of your event space, divided by the cardinality of your sample space. We got 1, 2, 3, 4 things in my event space. And as we already said, we got 15 things in the sample space. So there's a couple probabilities. Nothing too interesting. You can do some interesting stuff with probability, but we just don't have time in this class. So I will quickly move on to number 2. Number 2, we're told to answer questions about QBR, a quarterback rating. And what they tell us about quarterback rating is it's approximately normal. Okay, so it looks like that-ish. It's a pretty good one, actually. It has a mean of 50 and a standard deviation of 14. Okay, geez, hard to draw straight lines. Whatever. 50 plus 14 is 64, plus 14 more, 78, and 14 more, 3 standard deviations gets me close to the tail here, gives me 92. And you subtract 14 and you get 36. Subtract 14 again and you get, what, 22? And subtract 14 again and you get 8. And what it says is sketch a distribution and shade the area that corresponds with the quarterback having a better QBR than Alex Smith, who has an 81.1. All right, easy enough. 81.1 is bigger than 78, less than 92, so it's somewhere in here. Maybe I'll label it up top. And all this area out here represents the probability of somebody having a better quarterback rating than Alex Smith. Number 2 says, do that again. All right. Oh, could be better than that. Maybe. So there's not a bad bell curve. And you got the exact same distribution. So my mean is 50. And then 1 standard deviation over we said was 64. 2 was 78. And 3 was 92. And 1 standard deviation below was a 36, 2 was a 22, and 3 was an 8. And it says, sketch a distribution and shade the area that corresponds with the quarterback having a QBR between those of Michael Vick, who is a 51. I don't really like Michael Vick, so it's good to see him struggling a little. This would be 51 right here, just slightly above 50. And Russell Wilson, 34. Well, 36 is here. So 34 would be somewhere in there. And so the area in between them would be all of this stuff. Okay, so I guess that's all I got to do there. Which is greater, this or this? Well, might help to have an empirical rule. I mean, you might be able to just look at the picture and this looks less, this looks more. But if you're, one way to do it is to say, maybe I'll switch colors here. I've already used that color. I could say this area, maybe note, this area is less than 2.5%. How did I come up with that? Well, 2 standard deviations above and below the mean. So from 22 all the way up to 78 is 95% of the data. That's using the empirical rule. So what that tells us is that out on the outside, above 78 or below 22 is 5%. And since it's symmetric, half of that is above 78. So what that tells me is that the area above 78 is 2.5%. And this is smaller than the area above 78. So what I have shaded up here is less than 2.5%. Okay, what about this guy over here? I guess I can say note again. Note, this area is bigger than 34%. Why is this bigger than 34%? Excuse me. Because the empirical rule tells us that 68% of the data lies within one standard deviation of the mean. So between 36 and 64 is 68%. So using symmetry between 36 and 50 has got to be 34%, half of 68. And from 34 to 51 is bigger than 36 to 50, right? This is nested inside this. So this area is bigger than 34%. This area is less than 2.5%. So, which is the probability of a QBR better than Alex Smith is less. I guess it asks for what's bigger, right? Of a QBR between Vic and Russell is bigger. And I guess that's the end. That's the explanation, and that's the end of this problem.